Hello. Today we're going to be finding slope, which is very much like finding rate of change, except for we won't just be finding slope from tables. We'll be finding from tables still, but we'll also be finding slope from 2 points, which uses the slope formula, a graph, or a slope-intercept form equation. We're going to start with tables because that's very similar to what we just did with finding rate of change. Slope and rate of change, as long as you are talking about something that's a linear relation, is the same exact thing. So rate of change and slope mean the same exact thing for a linear equation. So the way we found rate of change was change in y over change in x. So slope is the exact same thing. Let's take a look at some example problems. To find the slope of each linear relation, we want to find the change in y, that'll become the top number of our slope, and then our change in x, which will become the bottom number of our slope. So my change in y is how do I get from one y value to the next? To get from -6 to -4, I add 2. And you can double check, but that's true all the way down, which it should be because it's linear. To get my change in x, how do I get from one x value to the next? To get from 1 to 2, I add 1. And that is also true as I go down my table. So then my slope, we use the letter m for slope. My slope, or my m, is going to be my change in y, which was 2, over my change in x, which was 1. You can leave it as 2 over 1, that's perfectly fine. Or if you realize, hey, 2 divided by 1 is just 2, you can also write your slope as 2. So 2 over 1 or 2 are both perfectly acceptable final answers for this problem. Let's try another one. So let's start with change in y. To get from -11 to -14, I subtract 3, so -3. And that is true as I keep going down my table. To find my change in x, to get from 2 to 4, I add 2. And that pattern stays the same as I go down my table as well. So my slope, or my m, is going to be my change in y, which was -3, over my change in x, which was 2. This fraction doesn't reduce, so we just leave it as -3 over 2. It will become more important when we actually go to graph, but always leave your slope as either a fraction or as a whole number. Do not change it into, like, for instance, don't change -3 over 2 into -1.5 or -1.5. For graphing purposes, it's actually easier to leave it as this improper fraction. So, finding slope from a table, exactly the same way as finding rate of change from a table. It's your change in y over your change in x. Sometimes, instead of giving you a table, they just give you the coordinates of 2 points, like you can see here in these next few problems. If that happens, the way we find our slope instead is by using our slope formula, which we have right here. To find your slope, or your m, you subtract y2 minus y1 and divide that by x2 minus x1. x1 and y1 are just the coordinates of the first point you see, and x2 and y2 are the coordinates of the second point you see. So let's dive right in and try one of these out. So for number 1, my first point is 11, -11. So x1 is 11, y1 is -11. y2, or x2 and y2 is my second point, so x2 is 0, y2 is 7. I like to write the slope formula out every time. You don't necessarily have to, but I think it's helpful. y2 minus y1 over x2 minus x1. Now let's sub things in where they go. I also like to put in this equal sign here just so I don't forget. y2 is 7 minus y1 is -11. So it's like 7 minus -11 up top. x2 is 0. x1 is 11. So it looks like 0 minus 11. Now I do the math. 7 minus -11, anytime you have a double negative, it's the same as adding. So instead of thinking minus -11, you can think 7 plus 11, which is 18. 0 minus 11 is -11. This fraction doesn't reduce, so I am all finished. My slope is 18 over -11, which is the same as -18 over 11, by the way. When you have a negative fraction, you can put that negative sign wherever you'd like, as long as you only have one negative sign in there. Let's try another one. So I'm going to start by labeling my coordinates as x1 and y1, x2 and y2. You are welcome to do this when you do this on your own. I'm going to write out my formula just so I remember where things go. I'm going to pre-set it up with those minus signs. Plugging things in where they go. y2 is 3, y1 is negative 20, so 3 minus negative 20. x2 is 16. x1 is negative 7, so 16 minus negative 7. Simplifying this out, 3 minus negative 20 is like 3 plus 20. So we end up with positive 23 up top. 16 minus negative 7 is really like 16 plus 7. So we get positive 23 on the bottom. I can reduce this fraction. 23 over 23, if I divide both numbers by 23, I get 1 over 1. Or you can think 23 divided by 23 is just 1. So you can write your slope as 1 over 1 or as 1. Those mean the same thing. If you have a fraction that can be reduced, I would like you to do so. I'm going to go ahead and pre-write my formulas here just so I have them. To save us some time, we go to plug numbers in. Okay. Next one. My x1, y1 is 15, negative 4. My x2, y2 is negative 5, negative 14. Let's plug the numbers in. y2 is negative 14 minus y1 is negative 4. x2 is negative 5 minus x1, which is 15. And so then let's do the math. Negative 14 minus 4, negative 4 is really like negative 14 plus 4. Either way you think of that, you end up with negative 10. Negative 5 minus 15 is negative 20. This is another one that can be reduced. First of all, negative divided by negative is positive, and I can divide both numbers by 10. 10 divided by 10 is 1. 20 divided by 10 is 2. So my best final answer when I reduce it is 1/2. Let's try one more like this. This is the most complicated stuff we're going to do today, by the way. x1 is negative 6, y1 is 18. x2 is negative 1, y2 is 3. Put things where they go in the formula. y1 is 18 minus, sorry, I did that backwards. Just kidding. Ignore that. Okay, let's try that again. y2 is 3 minus y1 is 18, so 3 minus 18. Down the denominator, x2 is negative 1 minus x1 is negative 6. 3 minus 18 is negative 15. Negative 1 minus negative 6 is like positive 6. So I end up with 5. That can be reduced, so let's do that. I can divide both numbers by 5. Negative 15 divided by 5 is negative 3. 5 divided by 5 is 1. Or you can just straight up think, what is negative 15 divided by 5? It is negative 3. So you can either write negative 3 over 1 or 3 as a final answer for those two, or for that one. The last couple ways we're going to find slope don't really involve any sort of calculations. So it involves looking at a picture or looking at an equation. When we're finding slope from a graph, we're going to count, you may have heard this before, as rise over 1. It's the same idea as change in y over change in x. Your rise, or your top number of your slope, is going to be however you move up or down to get from one point to the next. Your run is how many you move to the right to get from one point to the next. So we always go left to right, like reading a book. If we go up, it's going to be a positive slope. If we go down, it's going to be a negative slope. So let's try one out. My slope, how do I get from the point on the left to the point on the right? I'm going to go up 1, 2, 3. So the top number of my slope is going to be positive 3. I go to the right 1. So my slope is 3 over 1, or you can think what's 3 divided by 1 is 3. Either way, I get a positive slope because I was moving up as I go to the right. For the next one, notice to get from the point to the right to the point on the left, I'm going down, so I'm going to have a negative slope. To get from this point to the next one, I'm going down 1, 2, 3. Since I went down 3, the top number of my slope is negative 3. to how many am I moving to the right? I'm going 1, 2, 3, 4, 5, 6, 7. So then the bottom number of my slope is 7. So that fraction does not reduce. My slope is negative 3 over 7. Let's try another one. This one will be a positive slope because our line is going up as we go to the right. Looks like it's going uphill. So how many am I going up? I'm going up 1, 2, 3. So the top number of my slope is positive 3. How many am I going to the right? 1, 2. So my slope is 3 over 2. Positive because it's going up as I go to the right. Don't need to reduce that because it cannot. Last graph. How do I get from the point on the left to the point on the right? First, I'm going down. I'm going down 1, 2. Since I went down 2, it's going to be a negative number for the top of my slope. How am I going to the right? 1. So I can write my slope as negative 2 over 1, or negative 2 divided by 1 is negative 2. So either it's negative 2 over 1 or negative 2 for my slope there. So in general, a positive slope looks like this. A negative slope looks like this. Positive slopes, you're going uphill as you go to the right. Negative slopes are going downhill as you go to the right. Last thing we're going to do is super, super easy. Finding slope from an equation. You've probably seen the slope-intercept form equation before. Slope-intercept form equation is y equals mx plus b. Typically speaking, we have numbers filled into the m spot and the b spot. The number that we care about today is the number in the m spot because all we care about today is slope. So the number in front of x, or the coefficient of x, m, is your slope. So whatever number is in this spot right here is our slope. So all we're going to do is look at these equations and say what number is the slope. For this first one, the number in that m spot is 2, so my slope is 2. For the next one, the number in front of x is 7 over 2, so the slope is 7 over 2. No calculation here, just knowing where to find it in the equation. For the next one, the number in the m spot, the number in front of x is negative 3 over 4. I don't know why I wrote y there. What I meant to write is my m, or my slope. My slope is negative 3 over 4. Last one, the number in front of x is negative 4, so my slope is negative 4. That is it for finding slope. We'll build on this with some graphing in the future. Have a wonderful day.